Hi, hello, welcome to Knowledge Center. In previous video, we have studied about serial communication. We understood what is serial communication and what are the types we have over there and what are the chips we are going to use in that. Now, in this video, I am going to explain some of the major parts which is very essential to understand before writing a programs for serial communication. Means if you want to write a program to receive some data or to transmit the data serially in microcontroller, we have to learn these basic concepts. So let us begin with that without wasting much time. Very first thing what we need to understand while writing a program is baud rate. So the baud rate is almost, in the previous video I already told you what actually it means is. The baud rate is nothing but number of bits transferred per second. That's what it means. Okay. So in microcontroller, we need to select some of the baud rates. Here let us understand how to select that baud rate and also what are the range of baud rate we have. So we generally have baud rates in the range of 1200. So 1200 is nothing but 1200 pulses or cycles or pulses will be transferred within a second. Next we have the double of it, that is 2400, next 4800, 9600, 19200. So these are the standard baud rates which have been developed by IBM. So those are the generally used in the world. Okay. So we have to understand now how these baud rates has to be defined. Okay. So I'll make it very simple. Let us not make it complicated. See, how to select baud rate is nothing but very simple. We are going to make use of timer 1. We use timer 1. As you already know, there are two timers. We have timer 0 and timer 1. So we make use of timer 1 to define or to decide what kind of a baud rate we are going to use. So now let's see how and what has to be given into timer 1 so that we can select the baud rate. Okay. So to understand that, let me draw one simple block which will be helpful for you to understand. See, we know that the crystal oscillator, the microcontroller is going to have a crystal oscillator and its frequency is of 11.0592 megahertz. It is going to work on this frequency. So whenever there is a crystal frequency of 11.0592 megahertz, the system, the microcontroller will be dividing it by 12. Okay, it is going to divide that crystal oscillations by 12. So we have a crystal oscillator here and this is going to be divided by 12. So actually what happens when we divide it by 12? When we divide it by 12, we get a frequency of one machine cycle. So here one important thing you need to understand, machine cycle. See, one machine cycle is nothing but that is a minimum pulse which is required to execute an instruction. Okay. So let us assume that there is only one machine cycle required to execute an instruction. Now what is that machine cycle frequency? So we need to find out what is the frequency of that machine cycle. So that frequency of machine cycle will be done like this. Crystal oscillator frequency. This is the oscillator which is used in the microcontroller. And the 8051 microcontroller is going to operate on 11.0592 megahertz. Okay. So this 11.0592 megahertz will be divided by 12. It is a default value. So once after we divide it by 12, we are going to get a number 921.6 kilohertz. Okay. So 921.6 kilohertz. This is going to be a frequency of one machine cycle. So if you want to execute one instruction, we need one machine cycle and this is the frequency of that particular machine cycle. Now this machine cycle frequency will be given to a timer, but before that, when we are using it for a serial communication, we already told that we have UART. This UART chip will divide this machine cycle frequency, will divide it by 32. So further it is going to be divided by 32. This will be done by UART. Okay. The machine cycle frequency will be divided by 32. So once we divide it by 32, the frequency what we are going to get is 28,800 hertz. Okay, 28,800 Hertz. And this frequency is given to timer 1. So the frequency 28,800 Hertz is given to timer 1. When we give this frequency to the timer 1, there we can give some input to the timer 1, using which we can define the baud rates earlier what I have mentioned over there. Okay, so now we have to give some of the input to the timer 1, and then we can make use of this. We are giving this frequency to the timer 1. So whatever the input you give to the timer 1, that will decide what is the baud rate you are going to select. So I'll take an example and tell you how we can select the baud rate now. Okay, so just a minute. So if you want to select a baud rate of 9,200, if you want to select a baud rate of 9,600, sorry, then in the timer 1, the input what we need to give is -3. Give input as -3. So when you give input as -3, this timer 1 is having a frequency of 28,800 Hertz. So that 28,800 will be divided by 3. So this is going to give you 9,600. So this is how the baud rate will be selected. Okay, but -3 is nothing but you have to convert that into hexa. So in hexa, this is going to be FD. Okay, the conversion of this has been already explained in the previous videos. You can go through the description. There I have provided the link. Okay, so the FD is the input you have to give to the timer 1. So that by giving this, what happens? The baud rate selected will be 9,600. That's it. That's what you need to do. In that timer 1, you just give the input to FD. Then baud rate will be selected 9,600 automatically. Now how we got that 9,600? That is what I explained here. So for the timer 1, you have to set the frequency of 28,800 Hertz. Then only it will be selecting the baud rate like this. If you want to select some other number like 19,000 or 2,400, then you just divide it by the 12. So if you want to divide it by 12, you get 2,400. So you need to give -12 as an input for a timer 1. So -12 is nothing but in hexadecimal, that is going to be F4. Right. So these are the numbers which is what we need to give to a timers so that we define the baud rate. I hope this concept is clear for you. And if you want to know about timer 1, in the description I have given the link for timer 1 video. You can go through that, and also at the top end you can see I button. There also you have a link for that video which is going to explain you about the timer. Now let us see what is the timer 1 and how we need to use the timer 1. Timer 1 should be used in mode 1, that is an auto reloaded mode. Auto reloaded mode. So timer 1 must be used in mode 1, that is a auto reload mode. So what is this auto reload? What is this mode 1 in timer? If you want to understand this, if you don't have any idea, if you want to learn about that, then go through the I button. There you're going to get that timer 1 video. So there you will understand what is the T mode and what is that mode 1 and what is auto reload concept is. Okay. So as of now, I hope it is clear for you that how I got this baud rate by just giving an input so and so. So now I'll tell you one thing. I'll just put a table. If you want to select 9,600 as a baud rate in timer 1, you need to put -3, that is nothing but FD in hexa. If you want to select 2,400, you just put timer 1 as F4. Give the input F4 as an input to the timer 1. That's it. So if you want to get some other baud rate, like if you want to get 1,200, then you decide 28,800 must be divided with some number which will give 1,200. So what you can say, what you can do, 24. It divided by 24. So when you divide it by 24, when 28,800 is divided by 24, we get 1,200. Okay. So it's nothing but you have to give the input as -24. Now convert that into hexa. So -24, its hexa value is going to be E8. So put E8 in timer 1 so that the baud rate will be selected as 1,200. So this is how the baud rate has to be decided. Just use one instruction. Move. You can write an instruction like this. Move T1 hash. What is the data? FD. If I give that FD into this timer 1, then automatically the baud rate selected will be 9600. If you want to change, you can give any other address or data like this, it will select the baud rate. That's what the very simple thing. So this is the way of selecting the baud rate. I hope this is clear for you. So baud rate is important here to write a program. And now let's take up another concept, which is again a basic and important point to be known before writing a program. That is SBUF. SBUF. It is nothing but serial buffer register. It is an 8-bit register. Very simple thing. It's an 8-bit register. But the importance of this register is whenever whenever you want to transfer the data, means say I want to transfer some data serially, then the data has to be there in SBUF only. You put the data into SBUF and then it will be transferred. Okay, you cannot transfer the data serially from any other registers like accumulator, DPTR, R0, R1, R2. By there you cannot transfer the data. So I'll just give an example here. If you want to move for any destination, like say from Ballari to Hospet, if you want to move, if you want to travel, you need to be in an exact bus, the bus which is going to move towards Ballari to Hospet. If you sit in this other bus, it will definitely not reach the destination, right? So exact bus which is reserved for moving to Hospet, only in that bus you have to sit. Then only it will travel to the destination, right? Same way, if you want to transfer or receive a data, if you want to transfer data serially, then the data has to be there in SBUF register only. Okay, so this is a special function register used for serial communication. So just can move like this. Move SBUF and whatever the data you want, you put it 10H. So 10H is the data I want to transfer. First, before transferring it, first put it in SBUF. If it is in SBUF, then only it will transfer the data. So when you ask the system to transfer the data, the system will check for SBUF. If there is nothing in SBUF, that 00, nothing means there will be 00. So that 00 will be transferred. So I hope it is very clear for you that SBUF is a register which is used to transfer. When you are using a transfer concept, you should put the data into SBUF only. Okay. You can write it like this, or you can make a direct addressing mode, or you can make a register addressing mode like this. SBUF, comma, A. If I write like this, the content of accumulator will be given to SBUF, and then you can ask the system to transfer. Okay, so this is what the thing is about SBUF. And now if you want to receive, let's see how to receive the data. So someone is transferred, other system is transferring the data to the microcontroller. That is again serially received. So when it receives the data, where it will be stored, that is the point you need to know. So whenever the data is received serially, it will be again stored in SBUF register only. Okay, it will be stored in SBUF register. So whenever you receive a data, immediately you copy that data to some other register. Means how can you do that? Take like this, move A, comma, SBUF. So the content what you received in serially, whatever you received serially, that will be stored in SBUF. Immediately write like this, SBUF data will be given to accumulator. So temporarily it will be stored in accumulator. Because see, when you receive a data, definitely there may be another data which is going to be received by the microcontroller. So another data has to be again stored in SBUF in 8-bit register only. Means we have only one SBUF. So after receiving one data, one byte, there may be another byte which is coming to that same SBUF. So you have to clear that SBUF. So clear in the sense what? You take it and keep it somewhere. So that's what I am doing here. I am taking the data after receiving it. I am taking it and keeping it in accumulator. Just take it somewhere. Okay. You put it in accumulator. And so that it can be ready to receive another data. So this is the important thing you need to understand. SBUF is a register, serial buffer register, which is used to receive the data serially and also transmit the data serially. So if you want to transfer the data serially, first thing is you need to put the data in SBUF and then you can transfer. Or if you are receiving the data serially, the received data will be stored in SBUF. Immediately you take it to some other register so that SBUF can get ready to receive another data into it. Hope this is clear. So these are the things which you need to be clear before writing a program. Now one more important thing register is to be studied, that is SCON. This is nothing but serial control. Okay, it's a serial control register. Again, this is an 8-bit register. So 8-bit register will be mentioned. Each register is having its own values. So let me write it like this: SM0, SM1, SM2, REN, REN. After that we have TB8, RB8, TB8, RB8, TI and RI. Okay. So these are the 8 bits. Each bit is important here. So we can say that this is a bit addressable register. SCON, that is serial control register, is a bit addressable register. I hope you know what is bit addressable. If not, I will clear it. Bit addressable is nothing but you can handle any one bit of that. If you want to make this bit as 0, say this is D0, this is 0th bit of a register, D0, right? Then according to that, this is going to be D7, D1, D2, D3, D4, D5, D6, D7. So if you want to make this D1, D2, D3, D4, say this is D4, I want to make this D4 as 0, then what we can do, we can use the instruction clear and clear SCON dot 4. You can write it like this. SCON dot 4 is nothing but it will go to SCON register and its 4th bit. This is the 4th bit. So this 4th bit is going to be cleared, means 0. It will make it 0. If you want to make it high, you can write SETB set bit SCON dot 4. So without disturbing the other bits, we can just alter any of the one bit in that. So I am making, by writing this, what I am doing, I am making this particular bit high, right? So this is just an example I am giving that this register can be handled bitwise. Now let us understand what is the importance of this register and how this register is used for serial communication. Okay, so bit by bit I will tell you. First let us look into these two. So this SM is nothing but it's a serial mode. So if I give 00 here, it will be in mode 0. So if I give 01, it is mode 1. Similarly, we will have mode 2 and mode 3. If I give 10 and 11, these are the possibilities. So here for 8051 purpose, mode 1 is what important thing we need to understand. Mode 0, mode 2, mode 3 are not used in this 8051. So let us not bother about that. Okay, let us just understand what is that mode 1 happens. If I select 01 in this, it will select mode 1. So if it is mode 1, what it means? Let us see that. See, mode 1 is nothing but when you want to transfer a data, you have to, in previous video I told you that there is a data framing. Okay, so data framing is nothing but what? The 8-bit data will be covered with a start bit and a stop bit. So how many start bit you want and how many stop bit you need to define it now. There is a possibility of having 2 stop bit and also 1 stop bit. So when you select this 01, if you put 01 in this 2 bit, it will select 1 start bit and 1 stop bit with 8-bit data. So these 2 bits are used to frame, means to set the data framing. Data framing is nothing but the data which you want to transfer, that is 8-bit, will be having 1 start bit and 1 stop bit. So how to define it, how to frame that, so that decision is made here. If you just put 01, it is going to have 1 start bit and a 1 stop bit in between. So your 8-bit data will be there. 8-bit data will be having 1 start bit and 1 stop bit. So it is framed like this, and this framed data will be transferred. Okay, so that decision will be done here. So it should be always 01. So have one point in your mind that in this SCON register, I need to keep these 2 bits as 01 only. There is no other go. Let's not discuss about 00, 10 and 11 because they are not used in this 8051. Now SM2 is also, we keep it as 0 because that is also used for a multi-processor system, but this is a single processor. We don't have multi-processor concept here, so it doesn't comes under 8051. Okay, so let us make it 0 here. So what happens? These 3 bits are 0 now. Now let's look into the REN. So what is this? REN stands for, it is nothing but receive enable. Okay, so REN is nothing but receive enable, and this pin has to be high. You have to make it high 1. See, we have a control over serial communication. So if someone is calling you, for example, if someone is calling you, you need to have a control. You can block him, you can block that person, right? So that is nothing but a controlling. Man, same thing we can do it in serial communication. If other system is sending a data for you, it is your wish to receive it or not. So if you want to block it, if I don't want to receive any data, then what you need to do, you just put this as 0. You make this REN bit as 0, receive enable. So if you put 0, it is going to be disabled. So even there is a transfer, there is a other system which is transferring, your system will not receive the data, because if it is 0, right? And if it is 0, you can't even transfer the data. Okay, so if you want to have a serial communication, then it has to be 1. Why this bit is provided for you? If you want to block, then you have a control over that, right? So if this is 0, very simple, you can't transfer the data serially or you can't receive the data serially. If you want to make a communication, then this has to be 1. So these 4 bits, and these are the data fixed. You have to have these bits only, right? 0, 1, 0, 1. So in binary, what you can say in decimal, it is 5. It's representing 5. Okay. And now let us look at these 4 bits. What is actually the importance of TB8 and RB8? Here again, the TB8 and RB8 is again not related to 8051. So it is a general microcontroller, but according to our concept, we need to understand. So these two are again not related to 8051. So let us make it 00. So we are not bothered about this. Put 0. And these two are important for us. See, TI and RI. So transmit interrupt. TI is nothing but transmit interrupt. Okay. So whenever you receive a signal, see, whenever you want to transfer a signal, sorry, we are talking about transmit interrupt. So transferring interrupt is nothing but you transfer the data. When you transfer the data, first there will be a start bit and next 8 bit will be transferred. So after sending this 8 bit, there will be a stop bit. So when stop bit is in a off way, or when stop bit is transferred, at that time this bit is going to become high automatically. We are not making it high. So look at these pins. All these pins we used to give the input here, but these 2 pins are affected by the system. CPU will affect it. We are not going to make any change in that. So this is going to become high whenever the complete data is transferred. Simple case. If you are transferring some data, you need to get a signal that whether you have transferred it or not. The CPU should get a signal, right? So this is how the CPU is going to get a signal. Once it completely transfers the 8 bit and also the stop bit, then this is going to become high. That indicates the system that the signal has been transferred. You now take another data and transfer it. So it is, you get ready for transmitting the next data. That is what the indication we can understand here. Okay. So this is auto generated. System will generate this number. We are not going to do anything. By default, we put it 0 by default. But it is going to become 1 only if all the bits are transferred, and when it passes the stop bit also, at that time that is going to become 1. So while writing a program, you will make use of that. Okay. When we transfer the data, and we have to wait for another data to transfer unless all these 8 bits are transferred. So how we are going to come to know that this has been transferred? This is the bit you have to check. You check for this. If this is high, that is an indication that transfer has been done successfully. Now you can take another data into SBUF and transfer it. So that is how we are going to make use of it. And last one is receive interrupt. Receive interrupt is also similar thing. Whenever the data is received from the serial communication, other system is sending a data to your system and you got a data into that. So when you receive a system data, that data will be in SBUF. So when all the data is completely received, receive means we get all the start and 8 bit and stop bit. So at the off way of a stop bit, this is going to become high. This is going to become high. So when this signal is high, that is an indication that you have received a data in SBUF. Because when we receive a data, it will be stored in SBUF only. Okay. So what you need to do now? Immediately you have to take the data from SBUF to some other register. As I already told you, move A, SBUF. So that SBUF can become empty. Isn't it? So you take that immediately and store it somewhere in accumulator, so that SBUF can be used for receiving another data. If you don't remove that SBUF data, if you don't take up that data, then what happens? There is chance of overlapping. The another data may come and sit on this SBUF. So previous data will be missed. It is just something like this. You are getting a phone call. So when you get a phone call, you will be having a ring. Okay, you will be having a ringtone and it will be ringed. If you won't pick, you will lose that call. You will miss that call, isn't it? So same way happens here. When you receive a data, you take it and store it somewhere. If not, it will be missed because there is another data which is going to come and store in SBUF. So you need to get an indication that the data has been received. So this is the bit which is going to indicate a system by making it high when SBUF receives all the 8 bits to it. Okay, so this is also auto-generated. We are not making it 1. This is going to be auto-generated. By default, this is going to be 0. When data receives, this is going to become high and we have to clear it later. See, it's going to become high automatically, but we need to clear it. If you won't clear, what happens? That high will be same as it is. Then you will not get information that whether you have received or not. So you have to clear these two manually, but it is going to become high automatically. So we'll discuss more about this while writing a program. Now just up to this point, you understand these things here. So this is the important register need to be known for writing a program. So in next video, I'm going to come up with a programming concepts. Okay. Now till now it is very clear for you. This SCON register is going to be an important role, and the data what I'm going to give in the SCON is here we have 5 and here we have 0. So we have to move SCON hash 50H. So we have to give 50H to the SCON before going to a serial communication transmission or a receiving. We have to put 50 into SCON. Okay, so this is another line we got. So I hope this is very clear for you, and if it is clear, just press the like button, and also you mention in the comment box that what is the next topic you are expecting, what you want from us. Okay, so that it will help me to create videos. According to my plan, next video will be about the programming. But if you are feeling difficulty in any other concepts, you can put that in a comment box. Also share these videos among your friends and ask them to join my channel so that they can be perfect with the microcontroller concept. Thank you.